This is the second video in section 6.2, the derivative. And so here we're going to look at the function fxy is equal to x squared plus 2y. And we're going to do two things. We're going to prove that f is differentiable, and then we're going to calculate the derivative. Now, just like in Calculus 1, proving that this is differentiable using a limit is fairly intensive algebraically. So first of all, we start by calculating the two partial derivatives. So the partial derivative with respect to x is 2x, and the partial derivative of this function with respect to y is 2. So we start with our partial derivatives. We need those in our limit. Our function goes from R2 into R. So when we looked at the definition in the last video and we had all those x1 through xn, c1 through cn, and h1 through hn, all of those things we only have two of them. And so we're going to call our c1 and c2 simply a and b, and we're going to call our h1 and our h2 simply h and k. And so we're going to look at f of a plus h, b plus k, minus f of ab, because we're going to prove that our function is differentiable at the point ab, minus the partial derivative with respect to x, evaluated at ab times h, plus the partial derivative with respect to y, evaluated at ab times k, divide by, again, instead of the h1 squared plus h2 squared through the hn squared, we simply have an h squared plus k squared. We take the square root. And so we're going to evaluate this limit. I'll step out of the frame for a moment. I'll step out of the way of that limit so you can actually take a look at this. Now what we did is we substituted a plus h, b plus k into our function f. So f of a plus h, b plus k gives us these two terms, minus f of ab. This is the minus f of ab right here. Our partial derivative with respect to x evaluated at ab is simply 2a, and we multiply that by h. And our partial derivative with respect to y evaluated at ab is simply 2, and we multiply that with k. And so we've gone from here down to here. Now, I'm going to allow you to work through this and simplify this algebraically. If you have any questions, you can ask me in class. But this fraction here simplifies to this. So now we are down at the limit as hk approaches 0, 0 of h squared divided by the square root of h squared plus k squared. This fraction is less than or equal to this one because we're dividing by less. So we've taken our denominator, we've decreased our denominator, so we're dividing by a smaller number. That increases our fraction. H squared divided by the square root of h squared. What's the square root of h squared? It's the absolute value of h. So h squared divided by the absolute value of h is again the absolute value of h. This limit, as hk goes to 0, 0, absolute value of h is simply 0. That proves that our function is differentiable. The other part is find the derivative. So the derivative of f at any point ab is what? We evaluate f sub x at ab. So we take the partial derivative with respect to x at ab, and that's simply 2a. So we have 2a multiplied with x. The partial derivative with respect to y evaluated at ab is simply 2. So we have 2 times y. And so the derivative of our function at any point ab is another function.